2.1 prime factorization. I can find prime factorization.
Thank you, Cody. Nice job. All right, so we've got many vocab words to start the chapter. We've got fraction. Fraction's part of a whole. Second number, very important when finding prime factorization, is a prime number. A prime number is what, Tyler?
Multiplies by 1 in itself.
Okay, a prime number has two factors exactly. That would be itself and 1. Okay? A composite number then would be what? What's the difference between a prime and a composite? A composite number has what, Veda?
It has factors more than 2.
It has more than 2 factors. So obviously it has 1 in itself plus more, at least 1 more. Okay, and then a factor. We've been talking about factors. We should know what they are. It's a number that goes into another number, everybody. There you go. I love that. Prime factorization then would be breaking a number down into its prime numbers. When you multiply all of the prime numbers together, it gives you the number you started with. And then a factor tree is the diagram we use to do that. In this classroom, when you are finding factors, you are always finding factors using what? Raise your hand. When finding factors, you're always using what to find the factors of any number? So we have the number 12. How did we find the factors of 12? We use what, Maurice?
Vertically.
We worked vertically, but what are 1 and 12, 2 and 6, and 3 and 4? What are they, Isaac?
Factor pairs.
You have to use factor pairs. In my room, in my class, with our work, you must use factor pairs to find all the factors of a number. So 12 wasn't too bad because there's only 3 factor pairs. But look at 600. 600 has many factor pairs. But all the factor pairs together make up all the factors for 600. And as I showed you yesterday, as you go down the left side, if you're doing factor pairs vertically, and then back up the right side, your factors should be listed in order from smallest to biggest. Does everybody see how that works?
Yeah.
1, 2, 3, 4, 6, 8, 10, 12, 15, 20, 24, 25, blah, blah, blah. Our last 2 factor pairs we found were 24 and 25. Because 24 and 25 eventually crisscross one another, because after 24 and 25 you would go to the next number, that would be 25. What does that mean if the numbers are crisscrossing one another? What does that mean, Grace?
You're supposed to end already.
You're done. You're done, right? Because if I am going through all my numbers 1 through 24, I would try 25 next and be like, wait a minute, I've already used 25, right? So you're done. So when the numbers actually crisscross one another, you know you found all the factors for that number. The most important part of the lesson then is down below. Don't forget about listing them vertically. The most important part of the lesson is right here. Factor trees. You must be able to do factor trees. Essentially what you're doing is you are finding factor pairs for every set of numbers you encounter until you find the primes. So here we go. You have the number 12. We said 2 and 6 go into our factor pairs for 12, yes or no?
Yes.
Is 2 a prime?
Yes.
So we circled it. Is 6 a prime?
No.
It's a composite, right?
Yes.
So 6 must have more than 2 factors. So you guys told me that 2 and 3 are factors of 6, right?
Yes.
Is 2 a prime?
Yes.
So we circled it. Is 3 a prime?
Yes.
Do we have any more numbers that are not prime?
No.
2 and 3 are prime, we're done. So we take all of our circles. We have 2 circled, we have 2 circled, and we have 3 circled, and we wrote them 2 times 2 times 3. I told you that I don't want them I don't want them listed in a row if you can turn them into exponential numbers. So because 2 happens twice, we call that 2 squared, right? And 3 right here only happens once, so we simply call that 3. You with me?
Yeah.
I'm up here still. Ignore the people coming in the room. We went down to the number 600. 600 had way more work. Look at our factor tree. We went all the way down to, let's see, 1, 2, 3, 4, 5. This was our 5th line of work. 5th line of work. Until we found all the prime factors for the number 600. We put them all together, and we came up with 2 to the 3rd times 5 squared times 3. Any questions?